Okay, this is a continuation of the equations of tangents lecture that we looked at. We're trying to find the equation of a tangent to the curve. And remember we said we needed two things for that. We needed the point where it hits the curve. It's a tangent, so it only hits at one point. And we need the gradient of that line. And we found the gradient by differentiating the curve and substituting in the x value. We're going to pick up at question number 4, which is on page 10 of. Okay, here we're given an equation y equals the cube root of x squared, and we're asked to find the equation of the tangent at the point where x equals -8. Now, we're just given the x coordinate, so the first thing we're going to do is go ahead and work out the y coordinate by substituting that x value in. So y is equal to the cube root of -8 all squared. Now when evaluating this type of thing, I can either square the number first and then take the cube root, or I can take the cube root first and then square. Both will give me the same answer. It's usually easier to find the cube root first, so then we have smaller numbers. Cube root of -8 is -2, because -2 times -2 is 4. Times by -2 again would be -8. So it's -2 squared, which gives me a y coordinate of 4. So my coordinates for this are -8, 4. Now I've got the coordinates, I'm going to go ahead and calculate the gradient. I'm going to do that by first differentiating. Before I can differentiate this, I'm going to have to use my indus rules to get rid of the root. So it's a fractional indus, and it's x to the power of 2/3, because the 3 is the cube root, the order of the root. When I differentiate, dy by dx is going to be equal to 2/3 of x. We reduce the power by 1, so 2/3 take away 3/3 is -1/3. Now I'm going to be substituting into this to find the gradient, so I'm going to tidy it up. The negative indus tells me that I can pop the x down beside the 3 to make it positive, and the third itself tells me it's a cube root. So this is the same as 2/3 times the cube root of x. Okay, so we're going to go ahead and use this to calculate the gradient. Okay, so we're calculating the gradient by substituting the -8 into our derivative. So it's 2/3 times the cube root of -8. Cube root of -8 is -2. So it's 2/3 times -2, which is 2/6, which is -1/3. So now I have a gradient and I have a set of coordinates, a point, so I can find the equation by substituting all of these things in using y minus b equals mx minus a. M we've just worked out to be -1/3. A was -8 and b was 4. So when I substitute these in, I'm going to have y minus 4 equals -1/3 times x plus 8. I'm going to multiply by 3 to get rid of that fraction. So 3y minus 12 equals -x minus 8. I'm going to move everything to one side to tidy up. X plus 3y minus 4 is equal to 0. So it's the same as the examples we did before. We've made sure we found both the x and the y coordinate. We've differentiated and substituted in to find the gradient. The only thing that's changing is the derivatives are becoming slightly more complicated, and we're having to use fractions and negative numbers for our coordinates and gradients. Okay, the last example for this, we're given a curve equation y equals 1/3 of x cubed minus a half of x squared plus 2x plus 5. And we're asked to find the coordinates of the points on this curve where the tangent has a gradient of 4. Now the question says points on the curve, so we're expecting more than one answer. That means that there is more than one place on this curve where the tangent will have a gradient of 4. Now we're not given an x coordinate or a y coordinate, but we are given a gradient, so we're going to start from that point. We're going to differentiate, so we'll do y by dx equals multiplying by the power, so 3 times 1/3 is 1, so I'm just going to leave that as x squared, minus 2 times 1/2 is 1, so I'm just going to leave that as x plus 2. Now we are told that the points occur when m equals 4, so I'm going to make this equal to 4. I'm going to rearrange it and solve it, because I want to find the values of x where this is true. And you can see it looks a bit like a quadratic, so I'm going to move everything to one side, and I'm going to hopefully be able to factorise and solve. If I couldn't factorise, I would be using the quadratic equation or completing the square. So x squared minus x minus 2 is equal to 0. Just moved everything to one side. Now I'm going to factorise. So I've got x minus 2, x plus 1 is equal to 0, because negative 2 times positive 1 will give me the negative 2, and negative 2 plus 1 will give me the negative 1. So the solutions for this are given by the fact that x minus 2 equals 0, or x plus 1 equals 0. So x must be equal to 2, or x is equal to negative 1. So I now have two x coordinates where the gradient on that curve is equal to 4. Just want you to get a visual idea of what this could look like. Here's a curve, and we've got two separate points on that curve where the gradient is the same. You can see these equations I've drawn in are parallel, and that means at this point down here, whatever the x coordinate is here, my equation has a gradient, the tangent has a gradient of 4, and up here at this x coordinate I have another tangent that also has the gradient of 4. They're just in a different place. We've so far identified the x coordinates of each of those. We still need to identify the y coordinates, but we've already got the gradients to help us to do that. Okay, so now that we understand what we're doing, we've got the two x coordinates. Let's just work out what the y coordinates are for each of those cases. So we'll start when x equals 2. And we're just substituting into our normal equation. So y equals 1/3 times 2 cubed minus a half times 2 squared plus 2 times 2 plus 5. 2 cubed is 8, and 1/3 of that is 8/3. 2 squared is 4, and a half of that is 2. 2 times 2 is 4, and we're adding on 5. I'm going to deal with the whole numbers first, and then sort out the fractions. So I've got 4 plus 5 is 9, take away 2 is 7, so I've got 7 plus 8 ninths, 7 plus 8/3, sorry. 7 is itself 21/3, so I've got in total 29/3. So the first point on that curve which has a gradient of 4, is 2 and 29/3. That's the first part of our answer. Now we need to do sine for the second point. So when x equals -1, I'm going to substitute that into the original equation again. So y equals 1/3 times -1 cubed minus a half times -1 squared plus 2 times -1 plus 5. That's the same as -1 cubed is -1, so that's -1/3. -1 squared is +1, so that's minus a half. 2 times -1 is -2, and plus 5. Again, I'm going to deal with the whole numbers first. So I have 3, -2 plus 5 is 3. And then I'm taking away a third and taking away a half. I need a common denominator for these fractions. So I'm taking away 2/6 and taking away 3/6. 3 itself is 18/6. So I've got 18 take away 5/6, which is 13/6. So the second coordinate with the gradient of 4 is -1 and 13/6. We've now identified both points. Okay, so we already did the basics of equations of tangents. This was a backwards example. Just make sure you've understood what you've done. If you don't know any of the coordinates, but you're given a gradient for the tangent, what steps can you take to work backwards to work out the x and y coordinates? We're now in a position to continue exercise J. Questions 2 to 8, and they are level C.